You know, our planet is alive. Right beneath our feet, these huge plates of rock are constantly grinding and shifting against each other. It's a force that can build entire mountain ranges, a power that is just unstoppable. So, how in the world are we supposed to deal with that? Let's dive in.
So here's the big question we're tackling. How do you and I, how do we as humans, survive a force that can literally move the ground we stand on? I mean, it sounds impossible, right? But it's a challenge we've been facing for a long, long time.
And look, this isn't some abstract thought experiment. Millions upon millions of people live their lives, build their homes, and raise their families in these exact high-risk zones. So, this question, it's not just academic. It's about life and death. What can we actually do to keep people safe?
So how do we even begin to tackle a problem this big? Well, it turns out we actually have a framework for this. It's surprisingly simple, but really powerful. It's our toolkit for survival, and it all boils down to 3 key ideas.
Meet the 3 Ps: prediction, planning, and protection. Think of them as our 3 best lines of defense against whatever the planet throws at us. We're going to break down how each one works by looking at 2 very different but equally dangerous hazards.
Okay, so let's get into our first case study, earthquakes. You know, that sudden, violent shaking that is just terrifyingly unpredictable.
So that first P, that's prediction. And really, this is the holy grail, isn't it? Knowing exactly when, where, and how big a disaster will be. But, and this is a huge but, with earthquakes, yeah, this is where things get tricky fast.
And you can see why right here. Earthquakes are just incredibly hard to pin down. Yeah, sure, we've got seismometers that can map out fault lines and tell us which areas are at high risk, but that's over like decades. Knowing the exact minute a quake will hit, that's a whole other ballgame. And yeah, you hear those stories about animals acting weird beforehand, but honestly, it's just not reliable enough to base a citywide evacuation on.
And this right here, this just nails the point home. I mean, look at the difference. It's night and day. Predicting earthquakes is so difficult. But volcanoes, oh, they give us way more clues, as we're about to find out. So what do? I mean, if you can't see it coming, you've got to be ready for it when it arrives. Planning becomes absolutely everything.
And if you want to see planning in action, you've got to look at Japan. They have turned preparation into a national art form. Every single year, on September 1st, the whole country has a disaster prevention day. I'm talking about everyone, all across the country, practicing how to strap down their furniture, shut off gas lines, and pack those go bags. It's a massive effort to build resilience from the individual all the way up.
But planning for what people should do is only one piece of the puzzle. And that brings us to our 3rd P, protection. And this quote really says it all. Arguably, the most effective way to reduce the amount of deaths or costly damage is to protect the buildings. This is where the engineering gets absolutely heroic. So check this out. One of the coolest methods is called base isolation. What they do is they literally put the whole building on these huge rubber springs. So when the ground starts shaking violently, the springs absorb all that energy, and the building above, it stays pretty still. It's genius. Okay, so from the foundation, let's move up into the bones of the building. The walls themselves get beefed up with these strong crossbeams. It basically makes the whole structure way more rigid so it can stand up to all that violent twisting and shaking. All right, but for the really tall skyscrapers, things get even crazier. You're looking at what's called a tuned mass damper. It's this massive, heavy pendulum way up at the top. As the building sways one way, a computer pushes this giant weight the other way. It's incredible. It just cancels out the motion and keeps the whole skyscraper stable. All right, so that's the deal with earthquakes. But now, let's totally switch gears and talk about our second case study, the fiery mountain, the volcano. And you're going to see it's a completely different kind of threat, and it needs a whole different playbook. Okay, so remember when I said volcanoes are way more predictable? Well, this is what I'm talking about. They practically advertise that they're going to blow. You get these tiny little earthquakes as the magma moves around. The mountain starts breathing out different gases, like sulfur dioxide. The ground itself actually starts to swell up and change shape. We can even see it getting hotter with thermal cameras. It really is like the planet is giving us a countdown. But here's the thing. Just because you get a heads up doesn't mean you're in the clear. It just creates a whole new kind of problem. The challenge isn't knowing if it will happen, it's organizing a massive citywide evacuation before it's too late. Which brings us to protection, our 3rd P. I mean, if we can build earthquake-proof skyscrapers, we should be able to volcano-proof a building, right? Right?
Well, the answer is in this one absolutely terrifying number.
A pyroclastic flow, this superheated cloud of gas and ash, can hit speeds of 700 kilometers an hour. 700! There is nothing, no building, no tech, that can stand up to that.
So yeah, when it comes to protection, our options are pretty limited. I mean, for some of those slow-moving lava flows, we can try to fight back. We're talking huge operations, spraying millions of gallons of water to cool the lava, or digging massive trenches to steer it away. But against the big explosive ones, forget it. It's just not going to work.
Which is pretty wild when you think that, historically, one of the main ways people tried to protect themselves was through belief. They thought the mountain was angry, and the only way to calm it down was to give it offerings, sometimes even human sacrifices, just to appease the volcano.
Okay, so let's tie all this together. We've used the same 3P framework, prediction, planning, protection, to look at two totally different dangers. So what's the big takeaway?
This table really lays it all out. With earthquakes, prediction is a nightmare, which means planning, well, planning is everything. It's what keeps you alive. And protection, yeah, our engineering is amazing, but it costs a fortune, right? So not everyone gets that same level of safety. For volcanoes, on the other hand, we're much better at predicting them. So the whole game shifts to planning a massive evacuation. And protection? Well, against a big one, there's just not much you can do.
You know, at the end of the day, we can't stop the ground from shaking or the mountains from erupting. All we can really do is get smarter about how we share the planet with these incredible forces. The 3Ps are what we've got right now, but it leaves you wondering, right? What's that next big idea? What's the next great innovation that's going to help us live alongside the awesome power of our own planet?